Are we good?
Yeah, you good?
Okay, welcome to Functional Programming with Haskell. I'm going to be mainly focusing on the Haskell language, and we're going to be learning some functional programming concepts through it. Now, the first link I provided is to a site called Replit. This is an online compiler that allows you to enter code and run it without having to download anything. This link takes you straight to the interpreter for Haskell. And the second link is a bit.ly link that leads you to these slides if you want to follow along on your computer. If you have any questions, email me with that email right below my name. So let's begin. Now, a lot of you are probably wondering, what is functional programming? It is not programming that works. It's not programming that is functional in the common sense. It means that everything is treated like it's a function. Like the number 5 is like a function, f of x is obviously a function, and so on. A lot of languages have functional capabilities. Like I'm sure you've heard that Python and JavaScript have that, where you're able to input a function, or you're able to use a function as an input in a different function, and you can operate using that. While Haskell stands out because it is a purely functional language. You may have heard about a different language with a similar name called Pascal with a P. This is not this language. That's a much, much older language, and it is not a functional language. Haskell is a more modern functional language. Okay, so what data types are there? We have Booleans. These can only be true or false with a capital T, and everything else is lowercase. We have numbers. There are many, many different types, and I'm not trying to get into it. For this, we're only going to work with integers. A specific type of integers, but we're only going to work with integers. We also have strings. In Haskell, it's literally defined as a list of characters. If you want to look it up, you can see it's actually written in Haskell code, which is really cool. It's just a renaming of a list of characters, and that is a string. The way to write it is the same in many other languages. You use double quotes, and you put all the characters inside. Now, a character is just a single letter or symbol in single quotes. Again, multiple characters all together in a list make up a string. Now, I mentioned lists, but what are lists in Haskell? Lists in Haskell are really comparable to linked lists in other languages like Java, in that you have a head and a tail. I'll get more into that later. But the idea is that lists are expandable, ordered collections of the same type of data. So you can have a list of characters, a list of strings, a list of lists of integers, but it has to all be the same. So here are some examples. The way you write it is by writing an open bracket, and then all of the elements you want to be in the list, separated by commas, and then a closing bracket. Now, if you don't want to have anything there, this is what I call the null list. I'm going to be using this term throughout the course. It's just the open bracket and end bracket with no commas or any elements. If you want to have 1, 2, and 3, it's open bracket 1, 2, 3, an end bracket. And here's a list of strings. Yeah?
Is a null list the same as null? Or is
No.
It's an empty list?
It's an empty list. In this language, null's a little more abstract. I won't be getting into the typing system of it, but what helps Haskell stand out from many other languages is there's actually no object tree like you're probably used to. Like in Java, you can have classes extend for other classes, and classes are ways to describe what an object would be. You don't have that same kind of thing in Haskell. So there's no null, but you can arbitrarily make your own. So in this case, when we're working with lists, I'm going to refer to the null list as like the least value list with the most empty you can have. So because of how some interpreters work, for example, Replit, the link I gave you, you need a main function. Not all of them require this. I've used some that don't require it, but this one does. So to be very, very simple, we're just going to write the first line, and we're going to keep it this way. Main equals print hi, or hello world, whatever string you want. So whenever you press run, the way to run your code, the specific function you want, you read all your commands out, like I did, in the Replit over here. And I have a main function defined. If I want to call my functions, I have to hit run, which then interprets all of my commands that I've written. And then off to the right, you can see I'm able to call next to the yellow arrow my function. Now you may notice something a little odd. There's no parentheses. It's factorial space 5. This is how you call functions. You have the function name, space the first input, space the second input, and so on. There's no parentheses and no commas for inputs. This is simply a syntax thing. This can apply to some other things, but we're not going to be using that. So whenever you make an edit to your code, rerun it, and then call your function to see the new output. So, function design. How do you design a function? It looks a little different than Python or anything else you've seen. The way we do it is we say the name of the function. In this case, we're going to name it f. It can be anything. But the first letter should be lowercase, preferably camel case. It doesn't enforce camel case, but that's what I prefer. And then you have all the inputs separated by spaces. So if we want to do just f with no inputs, we can say f equals. After all the inputs, you put an equals in the output that's desired. So let's say we want the function a to be 5. We just write a, which is the name of the function, space, there's no inputs, so we're not going to write any, equals space 5. You can try writing that, and then go in your console, and then call a, and you'll see it'll return 5 every time. Now, if you want an input, what you do is you do f space n, meaning the name of the function's f, we take an input of n, and f of n is equal to n plus 1. G of x of y works similarly. It's g space x space y equals, and then mathematical equation, which sums x and y and subtracts 5. Something to know about parentheses, it's only used to denote order of operations, nothing more. Okay, so you're probably wondering, how can I get differing behavior? Like, how am I supposed to write factorial, or something that I would need an if statement for? One of the ways to achieve this is through something called pattern matching. The way Haskell works is it reads your code top to bottom whenever you make a call, and it tries to match the pattern. So factorial of 0, I can literally say factorial space 0 equals 1, because factorial of 0 is 1. So if I write factorial of 0 in the commands, in the off to the right in replit, it will output 1, because it matched the pattern to that line. And then, because I know that if it is not 1 is the input, it is able to continue onwards. The next line will read factorial of n equals the common formula, which is n times factorial of n minus 1. Do we have any questions with this?
So does the order matter?
Yes. The order does matter because Haskell reads top to bottom. Yeah?
What are you doing here? As in, like, what is this all for?
What do you mean? This is making the factorial function.
Okay.
We're just trying to, you know factorial from math?
Yes.
Okay. Any more questions before we continue? Yeah?
What would change if you switched the order in this case?
The issue is that if I were to call factorial of 0, it would immediately go to factorial of n. It does match that because n could be any number, right? So then it's set factorial of 0 to be 0 times factorial of, and just because it's multiplying 0 by something doesn't mean it'll stop executing. It'll try and get the full expression, which is not the behavior we want. So that's why we have this. Now the way it works is it sees, let's say I'm trying to execute factorial of 1. Factorial of 1 does not match the pattern of factorial of 0. It does match, however, factorial of n, which is the line after, because n can be any number. So therefore, factorial of 1 is equal to 1 times factorial of 1 minus 1, or factorial of 0. Well, what's factorial of 0? Factorial of 0 would match the first pattern, which sets it to 1. So then we can go back to the original statement where we said 1 times factorial of 0, which is really 1 times 1. So factorial of 1 is equal to 1. It's similarly for all numbers greater than 1. You just recur more times. Here are some built-in functions I've been using before. They should be very familiar to you. Addition, subtraction, basic math stuff. You put it in the middle. Something to note though, not equal to, instead of using exclamation mark like most languages, it's a slash. and not and and or are actually spelled out in English. Now, you probably have a fair point when you're thinking, there's no way pattern matching accounts for all issues. And you're right. I can't test to see if a list has a length of 2 in pattern matching. I just can't do that. What I can use is something called a guard. Guards are very similar to if statements. The way you write it is you write the function name, then all the inputs separated by spaces. You go to a new line and tab in to denote it's still the definition of that function. You use that bar character. You write the condition, which must output a Boolean, by the way, and then equals, and then the value, if that's true. And you were required to have an otherwise statement, otherwise known as else in if statements, because a function must always output the same type and it must output something. So if we were to rewrite factorial of n, we write factorial space n, and the way you would read is if n is equal to 0, then factorial of n is equal to 1. Otherwise, if none of the above conditions are true, then factorial of n is equal to n times factorial of n minus 1. Any questions with this?
Do you have a problem with n less than 0?
Yeah, you can't calculate n is less than 0. You're completely right.
Right, but say your code crashes.
What?
Does your code crash in that case?
It would run forever. So yes, it would crash. It would time out. But most cases when you're computing factorial, you're not looking for, you can add an extra condition if you want. Right above n equals 0, you can do n is less than 0 and just output -1 or some number like that. Does that answer your question? Cool. Okay, so lists. As I mentioned before, they're really like linked lists, where you refer to it as a head concatenated to a tail. By that I mean, if I were to do 5 concatenated to the no list, that really is open bracket, 5 end bracket. Does that make sense? Do we understand how to concatenate? Like in English? So concatenating, what it does is it takes some value and put it in the front of that list. The way we concatenate in Haskell is by using the colon command. So 5 colon the no list, the list with no elements, is really equal to the list of just 5 when you execute it, because it adds 5 to the front of the no list, which makes it the only element. So internally, when we represent lists, it's really 1 concatenated to the list of, 2 concatenated to the list of, 3 concatenated to the list of, 4 concatenated to the list of, 5 concatenated to the no list, which is the list of 1, 2, 3, 4, 5. We can write it normally like the list of 1, 2, 3, 4, 5, like as we're used to, but internally that's how it works. This is important to understand because there's these 2 functions we're going to be using a lot today. One called head and one called tail. The head function takes a single input, which is a list function, which is a list, and it outputs the very first element in the list. Tail outputs the list of everything but the first, retaining the order. So if I were to get the head of 1, 2, 3, 4, 5, does anyone know what that would be?
1.
Correct. What's the tail of 1, 2, 3, 4, 5?
2, 3, 4, 5.
Exactly. And the type of head is always going to be the value of the thing in the list, and the type of tail is always going to be the list. Okay, so hopefully everyone has replit out. Do we know how to write the second of a list? We want to get the second element of the list, and we can assume that the list is at least 2 long. Does anyone know how to do it? Yeah. You take the head of the tail of the list, and I'll give you the second. Good job. Okay, so let's write a length of list function. If you guys know any Haskell commands, don't use the built-in one. So this is how you write it in Python, right? You see if the list is null. If it is, return 0, otherwise return 1 plus the length of the rest of the list. So how can we write this in Haskell? Does everybody agree with the first line? Do you understand how I came to that conclusion? Yeah? Because the idea is that the null list is length of 0. Otherwise, we have some list that we know is not length of 0. What is it going to be? Does anyone know? What's the first blank rather?
1 plus length of list? Or list minus?
You're close, you're close. So yeah, you're right. We were adding 1 to the idea is we want to get the rest of the list, right? So how can we do that? You were right when you said tail. So it's 1 plus the length of list of the tail list. Any questions? Okay. So this is built in, as I said. The function is called length, and you input a list and it gives you a length of a list. Now to test if it's null, I really recommend just using the comparison double equals to see if it's null, rather than using this function to test if the length is 0. Because I won't get into it, but the double equals is actually faster. Now, list comprehension. This is a very powerful tool which allows you to quickly generate lists of information with a certain pattern. The way it works is you first specify what you're doing to the list variables. It can just be it itself, but you can also do some functions or some manipulation to them. Then you write a bar, and then you say where you're getting these list variables from. So you say list variable A, or just A, and you draw a little arrow, comes from this list or some sequence. And you write a comma, and you can do all the list variables you need. And then you have all the conditions in which A and B and those variables will only be used if and only if that condition is true. So let me explain more. Let's say we define lists to be 1, 2, 3. In the example I've written, I've said we want a list of all the elements being A plus B, such that A becomes all of the elements in list in order, and B becomes all the elements in list in order, such that A plus B must be greater than 2. So, it would never add 1 on 1. Do we know why? We would never see 1 plus 1 in the output. Because it's equal to 2, which is not greater than 2. Exactly. So that's why you would never see 1 plus 1, because A and B cannot be 1 at the same time, because it would not work with the condition. So that's why we see the output would be 1 plus 2, because it'd be A would be 1, B would be 2. A would still be 1, B can become 3, right? A becomes 2. Now B can be 1, A is still 2, B is 2, and so on. And you get this long, weird ordered list. A useful tool we're going to be using is something to quickly get a range of values from A to B. The way to denote this is use an open bracket A dot dot B. It goes by ones, if A and B are integers, by the way. Something nice about Haskell is you can make an infinite list of infinite length. Do not call the length function of this, it will not end computing. But trust me, it's infinite. The way you do this is you say the number you want to start at, and so on. So open bracket A dot dot end bracket. So let's make a list that contains all even numbers greater than or equal to 2. I'm going to give you a couple minutes to think and then tell me what the blanks are. Do we know what the first blank would be? Do we know what we want to make A? Like become? Do we know what all the numbers we want A to be? Yeah, we're right, but let's write a condition about it, because we can't go every other, right? So let's just, how many numbers do we want? Yeah, exactly. So what infinite numbers would we want? And then we can try and do a conditional to eliminate all the ones we don't want.
Could you do a sequence of numbers like 1, 2, 3, 1 dot dot or something?
Yeah, exactly. So we're going to go from 2 onwards. You can do 1 onwards, but we know that 1's odd. So there's no point in that. What would be this second blank? How are we now that we have all the numbers that are greater than 2, all integers that are greater than 2, how are we going to filter out all the numbers that we don't want, the ones that are not even?
If we do like 2 times a mod 2 equals.
Yeah, exactly. Were you going to say the same thing? Perfect. That's exactly what I wrote. So a mod 2 equals 0. What a mod 2 does is it sees if you divide a by 2, what's the remainder, right? If the remainder after dividing a by 2 is 0, then it must be even. Since this is the definition of being an even number. Definition of being an odd number is a mod 2 would be 1. Okay, let's do something a little more complicated. Are we all familiar with Quicksort? I'll give a basic rundown anyways. So the idea is you have 3 parts of the list. You have the part to the left, it's your left. The part to the left, the pivot, and the part to the right. And we decide what goes in each group by the pivot. The pivot's a single number. And we're going to say everything that's less than the pivot must go to the left. Everything that's greater than or equal to the pivot must go to the right. And then what we do is we sort everything on the left, and we sort everything on the right, and then we put the left here, the pivot here, and the right here. And that guarantees that we have a sorted list. Does everyone agree with that? Then it must be sorted? Cool. And then we just append it all together. This is how you do it in C. You're going to see that in Haskell, it is not nearly this many lines. And this is being generous to C, because this is pretty short code. I've seen much longer implementations. But first, let's break it down into smaller functions. Let's write a getLower function. Who knows what we want this to do? So the idea is we're going to have a list input of all of the numbers, and we're going to have a number that we want to get all the numbers in the list that are lower than. Basically, all numbers that are less than x in list, we want the output to be. And we're going to try writing this using a list comprehension. Does anyone have any ideas? Do we understand the problem? Yeah? Cool. Yep.
So could you say A is equal to list?
Yeah. A becomes list. And what should the second blank be? What is the condition in which we want to include A? Someone over here? No? Okay. Yeah, exactly. A less than X. X, sorry. Exactly. So this would give us all the lower numbers, all things that are lower than X in list. Keep this function in Replit. And I'm going to move on because you guys have the slides, hopefully. So now let's do the same thing, but get larger. Does anyone know what this would be? It's going to be very similar to the last one. Yeah, greater than or equal to, because we want to, in case you have duplicates, right? Duplicates of the pivot. Okay. So, do we understand why the first line? Because it's quick sort of the null list. How do we sort the null list? What is a sorted version of a list with nothing in it? A list with nothing in it. Yeah. So, how are we going to sort the list, assuming it's not null? Think about it for a bit, and then let me know when you have an idea. Raise your hand when you do. more importantly, let's think about the problem of what should be the pivot. What's something that we can easily access that we should base everything off of? Anyone? Yeah, exactly. We should get the head of the list, and that should be our pivot. And so the rest of the list is the stuff that we're going to try and put into lower and into the left and right. Does anyone need help writing this function? Okay, what are we thinking? How are we going to solve this? Do we know how to get the lower and greater than? How to call the functions? Yes, no. Who does not know how to call the lower than and greater than functions in this case? You don't? Okay, that's fine.
I'm going back in the slides and figuring it out.
Okay.
Where are the slides again?
The slides are, let me go back to the beginning. This link, the bit.ly. The way we call a function, by the way, is you say the name of the function, space the inputs. Do you understand that? Okay, so what do we want the pivot to be? Head of list, we agree? So what is the list of things we're trying to find that are less than the pivot? We're trying to get the tail of the list, right? So we're trying to see everything in the tail of list that is less than the head of list. To do this, we can use a function we already defined called getLower. Right? So we can do getLower, and the first input is list, which is the stuff we're going to try and be finding that is less than x. So in this case, it's going to be tail of list. Do you agree? Okay, so what should be x? Yeah, exactly. Now to denote it, you need to use parentheses. So it's going to be getLower space, parenthesis, and then you're going to write tail of list with a space in between, and then end parenthesis, and the similar pattern over here, where it's parenthesis, head, list, end parenthesis. And this will output all the numbers in list that are less than the head of list, right? And so since we want that to be first, we're going to, oops, this is the wrong slide. Okay, since we want to do this, we want it to be where we want to sort that first, right? Because we want to get the left, we want to sort it. We want to get the right and sort that. And then we want to put it all together where it's the left, pivot, and then right. To concatenate, we use 2 plus signs to put two lists together. So do you understand to get the lower and sort it? Okay, so you understand to get the larger and sort it? Okay, so then all you need to do now is append it together, right? Excuse me, Sayer. Are you raising your hand or? Oh, okay, sorry. Okay, so it's a little long, but this is the basic idea. We're going to sort the lower part of the list by getting the lower of the tail of the list such that it is lower than the head of the list, right? We already talked about that. We're going to call Quicksort on this whole list. We're going to append it to the list containing only the head of the list, which is the pivot, and we're going to append it to quick sorting of everything that is larger than or equal to the pivot. Does this make sense to everybody? Is how to do it? Cool. So this is a fun little comparison. This is made in 2 lines, while C is made in a lot longer. As you get used to Haskell, at least for me, I find it a lot easier to represent recursive functions in Haskell as opposed to imperative languages, which means things like C or Java, which don't have functional capabilities as well. It's just way simpler to read, in my opinion, and way more powerful, as you can see. It handles a lot for you, and it's a lot more visual. It's also very nice for using equations in math, because it's just the function name, all the inputs equals in whatever equation you want to write. Okay, so this is the part that makes it functional. This is probably the part that you've seen in JavaScript and Python, which make people say this is functional capabilities. This is because we're able to accept functions as inputs. So here's a function I named apply. It takes 3 inputs. F, which is some function we can define above, X, and Y. What it does is it calls F on X. Remember how this is the syntax for calling a function. Even though it's an input, it's allowed. And we add it to applying F of Y. So let's call G of U equal to U plus 1. If we were to call apply with inputs of G, 5, and 6, it would output 13, because G would add 1 to 5, add 1 to 6, and then we add the 2 together, thus getting 13. Do we have any questions with this? Because this is a hard concept for a lot of people. Yeah?
What would happen if you put a number instead of G?
A number instead of G?
Yeah.
It wouldn't work, because a number is not a function that takes multiple inputs. It has to take one input, otherwise Haskell will complain and go, hey, what are you doing here? I only accept 0 or 1 or 3. So a similar issue if you try and give it something that it takes 2 inputs, right? If I call mod, for example. Mod expects 2, but we're only providing 1. So it would not be able to operate. Yeah?
So you're always adding the output of the first and second input?
That is only in the case of the function I defined as apply. Because it calls f of y and adds it to the output of it calls f of x and adds it to the output of f of y. I can do something simpler. I can make another function called apply to, which has 2 inputs, f and x, and it equals f of x, right? So that would simply just make the first function be applied to the second function.
So the first line is you defining the apply rule, right?
I'm sorry?
The first line is how you define the rule. And
Yeah.
The third line is you actually using it.
Yeah, so just get rid of the word let, and that could be a command in Haskell, and I can write G in the line below. And I can call apply in like the replit terminal. Does that make sense? Okay, any more questions with this? Cool. So what if we don't want G to just be an input? It feels like a waste of space to write in a whole line G of U equals U plus 1. That's why we have lambda functions, otherwise known as anonymous functions. It's known as anonymous functions because they don't have a name. So the writing of it's a little wonky. It's been written back here, actually. The way you write it is by writing a backslash, not a forward slash, very specifically a backslash, all of the inputs separated by spaces, just like you would for any other Haskell function, and then an arrow pointing to the right. And that's the output. Now, if you're wondering, can we do pattern matching in this? No, we cannot. If you're wondering, can we do guards in this? No, we can't. You can use if-then, which is a function defined in Haskell. I'm not going over it because it just wasn't necessary for the stuff we're doing today, but I do encourage you to look it up. So for example, if I want to make an anonymous function that takes two inputs and adds them, I can do \x space y, arrow to the right, x plus y. And if I want to make a function that takes only one input, x, I can do \x, arrow x times 5, and this multiplies x by 5. Now, because of the way Haskell works, if you have a function and then all of its inputs afterwards, it'll operate on it. So we can write something like this in the line below, where we take the function that adds two numbers, surround that function in parentheses so Haskell knows order of operations, and afterwards write 3, then 4. And if you try that right now in Replit, you'll see it output 7. Because what it does is it accepts an anonymous function, then 3 and 4 will become x and y, and it adds the two numbers. Therefore, it adds 7. So we can use this on apply, where we completely replace g of u, where now it's just an anonymous function. That's simply where we have apply, and we define an anonymous function, surrounded by parentheses for order of operations, that takes one input x, and it outputs x plus 1. And we can still provide it 5 and 6, and you'll see it outputs 13. Because anonymous functions are treated a lot like normal functions, except they just don't have a name. Fun fact, you can set, for example, f to be equal to an anonymous function. The anonymous function doesn't have a name, but x now equals that function. Do we have any questions about this? No? Okay. So let's make a keep function. The idea is we're provided a function that takes one input and outputs a Boolean, true or false, and provided a list of integers. Let's keep it simple. And f must take in an integer as an input as well. What it does is it outputs a list such that every element in that list, if it was an input to f, it would be true. You can think of it like a filter, where if I have a long list of all the numbers, I can try and filter it out to get every number that is divisible by 3 by changing f to make sure that every number is divisible by 3. Let's use a list comprehension for this. You can use recursion, pattern matching. Up to you guys. But what do you think? Let's just do list comprehension for this. What do you guys think we should do? Just a starting idea. You don't have to get the whole solution out. Do we understand the problem? Yeah, of course. So the idea is I have a list and a function, and I want the output to be all of the elements in that list that if it was provided to f as an input, it would output true. Does that make sense? So f can be some form of a check, like if it's multiplied by 5, is it divisible by 2, right?
Like you could do a assigned to 1 to infinity, and then the condition at the end.
Yes.
The function applied at the beginning.
Yeah, that's exactly it. Except instead of a 1 to infinity for what a is going to become, let's make it go through all of the elements of list. Do we understand how we came to this conclusion? Does anyone not understand? Perfect. So if we want to have a list of all positive numbers, we can just call the keep function, where we provided the list of 2 to infinity, right? And we provided an anonymous function. That equal sign is supposed to be an arrow, sorry. Anonymous function that checks to see if the input mod 2 is 0. Do we agree that that's the same output as the previous thing that we did, that it's just all the positive numbers? Does anyone disagree that it works? Or not understand why it's the same? Perfect. Okay. So now let's make an edit function. Similar idea, except this time we want to simply apply f to every element in the list. F no longer just outputs a Boolean. It can output whatever type. It takes an input of an integer, it can output whatever. And list is a list of integers. So I can provide you edit with a list of numbers between 10 and 20, and the function to double all the numbers, to double its input. And what it would do is it now be every even number from 20 to 40, because if you double all the numbers between 10 and 20, you get that range. Any ideas? Where to start? I'll give you a couple of minutes to think about it. Yeah.
Is comprehension the only way to loop in Haskell, or is there a looping mechanism?
There are for loops and while loops, but I won't be covering it. You can do it if you want. You need a... I can't remember the exact syntax of it, but you can look it up. You can do this function both recursively and with a list comprehension, by the way. Either is acceptable. It might be easier to use a list comprehension for you guys. I'm not sure. Do whatever you're most comfortable with. But that's what I found to be true for most people. Does someone know where to start? Any ground ideas as to what we can do? Okay, so let's use a list comprehension, right, where we get A to go through every element in the list. Do you agree with that idea? So we can analyze every element of A. Every element of list, sorry. So what do we want to do to every element in the list? Do we want to have a special condition to eliminate characters, to eliminate different elements? Do we want to apply a function to it? At the end, what do we want to do?
You have A iterate through the list
Yeah,
while you apply the function on the head.
very, very close. So what we want to do is, so the first part before the vertical line, we're able to operate on A.
So F of A.
Exactly. Does everyone understand how she came to that conclusion? Does it make sense? Does anyone want to be explained why that's the correct answer? Okay. So she's right. You do f of A for every element in list. Or you can define it using pattern matching / recursion, where you say edit of f of the null list is null, right? Because there's nothing to change. Otherwise, you do f of the head of the list concatenated to editing the rest of the list. Who does not understand the pattern matching solution? Perfect. Okay, that's all I have. Any questions? If you do, feel free to email me. Have fun with whatever workshops you go to. Have good luck on your projects. So thank you for joining.